Hey guys, I just recorded some video and lost you, but we're just going to keep this here because that doesn't really change. You're still going to have to write this down. So what we just did was volume. Okay, volume is in this LaCroix can. It's the delicious coconut LaCroix. That's what's contained on the inside. In this Toblerone, it's the delicious chocolate. Okay, that's what John, he gets to consume this volume later. He asked for it, but I said I still have to make my surface area video. For an ice cream cone, it's the physical ice cream you get on the inside. For the Rubik's Cube, it's all the pieces that make this. For my rectangular prism that holds my coasters that my sister made, it's the wooden, or it's the inside part, the coasters, okay? So it's the inside. Surface area, however, what we're learning about today, I just spelled it wrong like 10 times, so that's why you kind of missed the funniness of that, since you won't ever get that video. So surface area is the outside of an object. Okay, so in this LaCroix can, it's the aluminum meant to contain the liquid. For this tennis ball, it's the felt used to create this object, okay, to contain the air on the inside. For this ice cream cone, it's this plastic, okay, plastic. For this rectangular prism, it's the wood that my sister used to make this in her woodshop class. For this Toblerone, the surface area is made up of the cardboard packaging, okay? So it's the outside of the object. So surface area is how much it would take to cover something. So what it takes to cover it. It takes to cover it. So that's like if you were to be wrapping a present. Now that's a bad example because when you wrap a present, you put like flaps and folds on things. So like painting the walls of your house, that would be it, because you don't have any excess. You're just painting the inside. Okay, surface area. So let's go ahead. Each of them has their own thing. But what's really important is you're just adding all the areas outside of a shape to make it work. So it's really important to start to piece together how the shapes are made. So like always, we're going to write down the formulas and we'll do some examples. So we'll start in order. I'm going to grab out my handy dandy order from our last notes. Our first is a cube. Okay, so to be able to find the surface area of a cube, so adding up all the areas on the outside of a cube. Well, if I know that a cube is made up of a bunch of squares, so a cube is made up of 6 identical squares. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I don't know. 1, 2, 3, 4, 5, 6. So 6 identical squares. So I would have to just find the area of one square and times it by 6. So my surface area, okay, my formula is going to be 6 times the length squared, okay? Because in this case, I am taking 6 squares, okay, and adding them together, which is the same as multiplying. And a square is length squared for the area. So I'm taking the area of a square, which is length squared, and timesing it by 6, because I have 6 identical squares. Rectangular prism. A rectangular prism is built of two sets of equal rectangles 3 times. Okay, so look, for this, again, this is different because it goes out a little bit. So for my sister to make this, she has this side, which is identical to the top. So the top and the bottom are the exact same. So 2 of the length times widths, okay, 2 of them. And the sides, she has 1, 2 of the same here. Let's call this the length times height. It doesn't really matter. And then here we have the height times width. And 2 of those that are matching. Okay, so the rectangular prism, you're just adding all 6 of the rectangles together that make this rectangular prism. There's 6 sides, and there's 3 sets of 2 matching. So your surface area, this is a long one, is 2 times the length times width, because you're finding this area is length times width, plus 2 times the area of the length times height, because that's how you find the area of that rectangle, plus 2 times what it takes here, which is height times width. Okay, so 2 length widths plus 2 length heights plus 2 height widths. So you're just making all the combinations you can for it. Okay. I'm gonna scoot this in so that way you can see it more. So 2 length height. It's 2 height width. Okay, that way you can kind of see it better. Okay, cube, rectangular, prism, check. Let's go on to the next one. Cylinder, okay? Cylinder, circle. Okay, a cylinder is like this can, okay? This can is made up of 2 circles that are identical, top and bottom. So you're gonna have your circle times 2, okay? So you're gonna have to find the area of the circle twice. And the area of a circle is pi times radius squared. Plus, here's what's crazy. Look at my piece of paper, that's a rectangle. When I wrap it around a can, it makes the outside part. So this part here is just made up of a rectangle. So the top, bottom are 2 circles, but the around, okay, this here, this lateral area, this is made up of a rectangle. And that rectangle is the height of the can times the outside of a circle. Does anyone remember what the outside or perimeter of a circle is called? We took notes on this. So again, this can is made up of, ooh, John, could you do me a favor? John, could you do me a favor? Could you cut a can so I could show kids? I usually do it with toilet paper rolls. Do we have toilet paper rolls that are empty? I'm trying to find a toilet paper roll. You cut this, open it, it's gonna be a rectangle. I always do it with toilet paper rolls in the class, but so see, this is the top and bottom are circles, then this is a rectangle that's just been sliced and circled over. So this is a rectangle is the height times the circumference, and the circumference is diameter times pi. So this is the height times diameter times pi. I know, guys, this is so confusing. So not only are you finding the area of circle 1 and circle 2, but then to get this around part here, it's the height of the can times the diameter, and circumference, and the circumference is diameter times pi. Remember, diameter is 2 times the radius. Okay, so the surface area, we're gonna have to add 2 circles together, so 2 pi r squared plus, oh, thank you, John. Here, this makes a little more sense. To show you the outside, how it's a rectangle. See that it's a rectangle? And that rectangle came from the circumference times the height of the cylinder. So see, the height is the circumference of the circle, the perimeter of the circle laid flat. Kind of cool, huh? Okay, thank you, John. So 2 pi r squared to get the area of the 2 circles, plus height times diameter times pi, because that is the area of that rectangle. Length times width, height times the diameter times pi, and don't forget the diameter is just 2 times the radius. Okay, we're cruising through. We only have 2 left. We're not going to do sphere. That's not a standard you need to learn. We're not going to do cone. That's not one you need to learn. So all we have left is triangular prism and rectangular pyramid, the 2 hardest. Okay, now let's do triangular prism. Okay, triangular prisms, okay, if I looked at this Toblerone box, which we are going to open for the sake of this video, and then John gets to eat it. So a triangular prism has 2 identical triangles. 2 identical triangles. So to find the area of these triangles, it's 1/2 base times height. We're going to use lowercase height. Show that it's the height of the triangle. 1/2 base times height, but we have 2 of them. 1/2 base times height, but we have 2. Then we have 1, 2, 3 rectangles. Now, in this case, because it is an equilateral triangle, that means all the side lengths are the same. That means these are 3 of the identical triangles, but that's not always the case, so we can't just times it by 3. We have to do each one individually. Now, to get the area of these, okay, to get the area of these rectangles, okay, this is the height. height. But then that's just the slant height, the side lengths of the triangle. So side length subscript 1, that means the first one. Oh, sorry, you can see that, guys. Side length 2, that means the second one. So side length 1, side length 2, and then side length 3. Okay, let's break that apart. So to get the cover of this, I'd have to find the area of both triangles. So 1/2 base times height times 2, because I have 2 of them. That's what we find here. Then the area of the 3 rectangles, okay, are the height times side length 1, the height times side length 2, the height times side length 3 to get the outside. Okay. I think I deserve a treat, don't you? Triangle full of chocolate. Isn't that rad? See? You can see that it's triangle, rectangle, 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 triangle. It's probably torture, huh? This is what you get. It makes these weird little triangle candies. It's like little mountains. I think it's supposed to be mountains like this, the Alps or something. Yeah, Swiss Alps. I think I said it was another kind of chocolate. This goes to John. John, thank you for your help. I'm not wanting it so much right now. Sweet. Oh, okay. So surface area here is the 2 times this. But you know what's crazy when you do take 2 times 1/2? That's 1. So we can just do base times height plus height times side length 1 plus height times side length 2 plus height times side length 3 to get the third one. Because this base times height is when we take 2 triangles plus the 3 rectangles. Okay. One last one. All we have left is this pyramid. Okay, we're gonna do a square pyramid. Okay, so square pyramid, that's like this, but this has a triangle at the bottom. So it's like it has the bottom, it has a rectangle, so only one of them. Plus, you have 1, 2, 3, 4 triangles coming up that are exactly the same. And the area of a triangle is 1/2 times base times height. Okay, because when you take a pyramid apart, you should have done this in your net activity. 1, 2, 3, 4. They're all going to come up together. Okay. 1, 2, 3, 4 to come up together. Does that make sense? So when I'm drawing this, it's like they're all coming up to that point. So the net activity could have really helped you guys like figure out what all these are. Let me see. We're going to try this again. So I have my square at the bottom. Then I have 1, 2, 3, 4 identical triangles. Man, good thing I'm a math teacher. My old mom, I'm an assistant principal, so. Okay, so, all right, let's go ahead and do the formula. Okay, so my surface area is, the area of a square is length squared. So the area of that square at the bottom that we found here is going to be length squared plus 4 of the same triangles. Well, guess what's cool? 4 of the same triangles, 4 times 1/2 is the same as 2. So if I do 4 times 1/2, that's 2. Base times little heights. Okay, because 4 times 1/2 is 2, 2 times base times height. Okay, all right. So now it's time to go ahead and use them. Okay, I'm gonna pause it. The next video will be using these. We'll do one example of each and be done.